Okay, so in this lesson, Unit 5, Lesson 4, we're going to be subtracting polynomials. So we have to do this both pictorially, symbolically, and concretely. So pictorially, showing the picture, we're going to use our algebra tiles. Symbolically means we're just going to do the algebra. And we're going to do like 3x plus, we're just going to use our symbols. And then concretely means we're going to put this into context, which is we're going to do some problem solving. We also have to be able to identify equivalent polynomial expressions, which is what we learned in Lesson 1. And then again, we always have to find errors in students' work, so we're going to practice some of that towards the end. So just as a review, we want to know what opposite means. So opposite from 2 decimal 4 is negative 2 decimal 4. The opposite of negative 10 is positive 10. Okay. So by definition, opposite numbers have a sum of 0. And we can also use that in polynomials, and we did that in Lesson 1 as well. So the opposite of 2x is negative 2x. And the opposite of negative x squared is positive x squared. Now you don't have to put the positive sign. I'm just putting it so that you guys see it. Okay? So some class examples. What is the opposite of each of the polynomials? Well, we have negative 5x, so again 5x, positive 5x. The opposite of positive 11 is negative 11. And the opposite of negative 24x to the power 4 is positive 24x to the positive 4. And again, we do not need the positive signs on either A or C. So we talked about numbers and we've just talked about monomials, but what about binomials and trinomials? So getting the opposite of a monomial is just like getting the opposite of a number. But let's see, using pictures, what the opposite of a binomial and a trinomial look like. So I'm going to use this example here. So if I want to sketch the opposite of the polynomial using the algebra tiles, my yellow tiles are positive and my red tiles are negative. So in your little workbook, you have a different legend. I think white is positive and black is negative. Okay? So if I want to zero out, remember, because I said the opposite has the definition of a sum equal to 0. So really, I have to zero out my algebra tiles by creating its opposite. So what's opposite from negative 3x squared plus 1 is positive 3x squared minus 1. And same thing here. If I need to zero that out, I put a red. If I need to zero out the yellows, the 3 yellows, I put 3 reds. And if I need to zero out 2 reds, I put 2 yellows. Okay, so that's what an opposite looks like in terms of using algebra tiles. Well, let's take that concept and put it into polynomials. Well, if I want to zero out a positive 2x, I need negative 2x. And if I want to zero out a positive 3, I need a negative 3. So negative 2x minus 3 is the opposite of 2x plus 3. Same thing with 4x squared minus 7x plus 3. If I want to zero out that trinomial, I have to put the opposites. So negative 4x squared is opposite from positive 4x squared. Positive 7x is opposite from negative 7x. And negative 3 is opposite from positive 3. So these two trinomials are called opposite polynomials. And the same thing with the last one. So I have a negative 2xy, I have a positive 2xy, and again, I don't need that positive there. I'm just putting it in just to make it just a little bit more clear to you guys. Negative minus 2y squared, I need a plus 2y squared. Plus 3x squared, I need a minus 3x squared. So these two trinomials are opposite polynomials. We're going to use this concept in order to subtract polynomials. In lesson 3, or sorry, I think in unit 3, we talked about, and I'm just going to write this down here. You don't have to write it down. If I had plus 3 minus a negative 2, you were taught that I write every subtraction statement as an addition statement. And what I do is if I change that to an addition, then I have to put this to the opposite, or I have to use its opposite. So I always add my opposite. So we're going to use that concept here. So when we're subtracting polynomials, you must remember to add the opposite of each term in the polynomial first, then combine like terms. So we're going to write all our subtraction statements as addition statements first, and then we're going to just add by collecting like terms. Okay, so let's see what it looks like in terms of algebra tiles, or showing those pictures first, and then we'll translate it over to the symbolic. So here, the first polynomial does not change because I'm not subtracting it. But the second polynomial does. So I'm just going to keep the brackets around it just to show that that's one polynomial. I'm going to change this subtraction to an addition statement. I'm putting a big plus sign there. Just like I did when I subtract an integer, I add its opposite. That's what I'm going to do here. I'm going to change that to an addition statement. I'm going to add its opposite. Okay. So noticing that I am putting the opposite polynomial in my brackets. So these two are actually equivalent expressions. Subtraction statement changes to an addition statement by changing the second polynomial into its opposites. So now all we do is we zero out. So I can't zero out anything with my x squared tiles, so I have negative 3x squared. I can't zero out anything with my x tile, so I have positive 4x. But I can zero out one of my unit tiles, so I end up with positive 1. So that's how you would use your algebra tiles to simplify. So let's just try one more before we go to the symbolic. So once again, let me just change this. The first polynomial we write as is, because we're not subtracting that one. We are subtracting the second polynomial though. So we write the first polynomial. I'm going to put brackets around it just to make sure that we keep them nice and clear. We're going to write our subtraction statement as an addition statement. I'm making it nice and big. When I do that, we have to put the opposite in. So opposite from red is yellow, opposite from yellow is red, and opposite from yellow is red. So I just added its opposite. We zero out. We don't have anything to zero out with my x squared, so it's 3x squared. We can zero out one of the variable tiles. We're left with 1x, or just x, and it's negative. And we have minus 4, because we have 4 of the red tiles. Okay, so now what we're going to do is I'm going to show you with the picture and also with the algebra tiles at the same time. So I'm just going to move this up a little bit just so that I have a little bit more room. So with the algebra tiles, I'm going to build my first polynomial, or my first polynomial. So I have 3x squared minus 4x. Okay, now be careful with your legend. Now that's saying the black tiles are positive and the white tiles are negative. So when you're drawing these, make sure your black tiles are positive and your white tiles are negative. So sorry, let me get back to this. Here's my first polynomial. I'm going to stick with mine as yellow just because they're nice and bright. My yellow is positive, my red is negative. I'm already going to switch this. So I'm going to switch this to a big plus sign. I'm going to switch that addition or subtraction statement as an addition statement. And I'm going to put the opposite of my second polynomial. So I'm going to put 2 red x squareds and 1 positive variable tile. And then we zero out. Okay, so we're going to zero out these two, and we're left with 1x squared. I'm just going to put it here. Actually, I should put it here. Let's put it here. I'm going to erase this. Okay. And then I zero out one of these. Those two are gone. That's a 0. And I end up with minus 3x. So that's how I would do it with algebra tiles. Well, let's just do it with plain algebra and do it symbolically, which just means the symbols. So my first polynomial doesn't change. And I'm going to just keep the brackets around it. I'm going to change my subtraction statement to an addition statement, and I'm going to do that by adding its opposite. So the 2x squared was positive, now it's negative. And this one was a subtract, now it turns to an add. And now we collect like terms. 3x squared and negative 2x squared is x squared. And my x's are like. I have negative 4 here and I have positive 1 here. So when I zero out, I get negative 3x squared, or sorry, negative 3x. And I have the exact same answer. So again, it doesn't matter if you use the tiles. If you're visual, draw. If you are mathematical, do the symbols. And if you are kinesthetic, actually use the algebra tiles. Okay, so that's the same one. Sorry about that. Okay, so now we're going to go and just use algebra. If you feel like you need the tiles still, please feel free to use the tiles. I'm just going to do the algebra. Let's see if we get the same answer. So my first polynomial doesn't change at all, but I am subtracting this polynomial here from that one. So I'm going to change that to an addition sign, and I'm going to change this to the opposite. So it was positive 3x, it is negative 3x, it was minus 5, I'm going to change it to a plus 5. Now we collect our like terms. I have 4x's, I have negative 3x's, so I'm left with 1x. Once again, I don't need to put the 1 there. I have negative 3 and plus 5, so once I zero out, I get positive 2. So here's a trinomial. Now we're like, in this one we subtracted binomials. Here we're subtracting trinomials. So same thing, 3x squared. That one stays the same, but that subtraction sign changes to a big addition sign, and let's put its opposites in there. So negative 7x squared minus 3x plus 2. This trinomial is opposite from this one now because I switched those tiles around. Okay, so now what we're going to do is we're going to zero out, or we're going to just look at our coefficients. So we have positive 3x and negative 7. Sorry, positive 3x squared and negative 7x squared gives you the negative 4x squared. Then we have these two, which are like. We have negative 6 and negative 3, so we actually have negative 9x. And then we have our constant terms. 4 and 2 is positive 6. Once again, if you feel you need your algebra tiles, because you're kinesthetic, please do it and then just write down your answer. Okay? If you need the tiles, please feel free to do that. Once again, first polynomial doesn't change. I change my subtraction to an addition statement by adding its opposite. So we're going to add the opposite polynomial to this one, which is negative a squared plus 3a minus 1. And now we collect our like terms. Our a squareds, we have negative 2 and we have negative 1, so we have negative 3a squareds. We have positive a and positive 3a, so we have positive 4a's. And we have negative 1 and negative 1, so I have negative 2. And that's my final answer. It's as simple as I possibly can get. So you can subtract polynomials vertically. Again, like a word of caution, if you like horizontal, stick with the horizontal. If you like the vertical, I'm going to show you how to do it vertically, and then you choose which method. Do not do them both. Choose which method you like better, and then go with that. So when I rewrite, I'm going to write my 3x squared, my 4x, and minus 1. I'm already going to change this to an addition when I do it vertically. I'm going to add its opposites. So I'm going to add a negative 2x squared. I'm going to add a positive 3x. And I'm going to add a negative 2 because that's its opposite. So when you do it vertically, you're lining up your like terms, but already change it to an addition statement. Okay, so now this is a little bit easier. 3 minus 2 is 1x squared. Again, you do not need the 1. Plus 7x. And then you have minus 3. Okay, I'm going to show you one more just in case you like this method a little bit better. I'm going to write my first polynomial. Whoops. I really need to get one of those little pens so you don't hear the clicking all the time. Okay, so there's my first polynomial. I'm going to change this to an addition. And then I'm going to look. Okay, this is my x squared. It lines up with this. It was a positive. Now it's a negative. So I'm collecting my like terms. This is an xy. That's an xy. It's a negative, so it changes to a positive. So it requires you to do a little bit more in your head, but the rest of it's a little bit easier. This is a y squared. This is a y squared. You have a negative. It changes to a positive. And we add these up. So negative 3x squared plus 1xy. Again, we do not need the 1. You can just write it as xy and then plus 6y squared. Okay, so if you like this method better, go ahead, choose one and go with it. Okay, so here I'm just going to stop this video. Or sorry, I want you to pause the video and try this one because this is one of those find the error, and then come back and we'll go through this as a class. So welcome back. So it says here a student subtracted like this. So 2y squared minus 3y plus 5, subtract y squared plus 5y minus 2. It's all in brackets. So they opened up their brackets. They went 2y squared minus 3y plus 5. They actually changed that positive to a negative. Y squared, look what they forgot. They just opened up the brackets and they just put minus y squared, but they forgot to change this, and they just forgot to change that. Okay, so that gets carried all the way through. I should put this in red. So that should be a negative. Here, let me just change it. I'll change it in red so that it's really, really easy to see. So this should be, would be helpful if I change it. Negative, that's a negative, and this should be a positive. So this should be a positive here, and that should be a negative right there. And then we go, so 2y squared minus y squared is y squared, which is great. Negative 3 and negative 5 is negative 8y. And positive 5 plus 2 is positive 7. Now this is a very, very common mistake that students make. So I want to make sure that you understand that when you open up these brackets, you have to take the opposite of all three terms, not just the first one, all three of them. So now what I'm going to have you do is practice, because this is, you know how to collect like terms. It's just that one extra step of changing that subtraction statement to an addition statement. So make sure you, when you do that, that you change the polynomials, you add that opposite, and I want you to do page 234 to 236, 4B, 5D. You guys get the rest. Hand in that assessment focus sheet to me. And also, we're going to do applications in the next video. So